Okay. Has everybody tried at least one from A, B, and C? Oh yeah, it should be -5. Sorry, I missed the negative. Yep. So it should be -7 and +2. Thank you, Joel. Lucas? Yes. Of course, you could simplify it. But that's not the point of the lesson I'm giving today. But yeah, you can. And you could. You should. Yeah, you would make that 2 root 10, and so it would be 4 plus or minus root 10 over 3. But that's not the point of where we're going today. But yeah. Okay, so everybody should be able to do this, yeah? Right? What we're doing here is grade 8 math, right? It's just substitution, yeah? But the question 4 asks, what patterns did you notice? Well, what did you notice with number 1 here? And I'm referring specifically to the answers. What did you notice? Lucas? There's only one answer, yes? The answer here was 4. There was no plus or minus situation, was there? The answer here was 4/3. There's no plus or minus there, is there? The answer here was -1/5. Everybody see that? Right? Everyone agrees? Okay. What did you notice in number 2? 2 answers. There was always 2 answers, yes? And even though they were ugly, there was still 2 answers, yeah? And what did you notice in number 3? Why did I stop? Is this allowed? A negative square root. That doesn't exist, does it? Right? So looking at that, looking at those 3 things, what is it about the quadratic equation that tells you if there's going to be 1 answer, 2 answers, or no answers?
Well, the 1 answer is minus itself and the squared.
What do you mean by minus itself?
Well, there's only 64 minus 64.
Right there, right?
Mm-hmm.
144 minus 144. 100 minus 100. Right? What do you notice in this one? Did the square root drop out?
No.
No, it didn't. The square root was present every time, wasn't it? And it was positive.
I'll get that later.
That's okay. Jessica has it. Nope, Shaq has it. Somebody has it. Don't worry about it. See, what a team. Yeah. Okay, so we noticed that. And then in the third one where there's no answers, what did we notice? That it's a negative square root. Why? Why are there no answers to 3, A, B, and C? Because you can't do a negative square root, yes? Okay, we're going to come back in a moment, and we're going to do all this with the calculators, like I say on that page. But I want to finish this thought right now. And that thought is this right here. Okay? This section, all right? The square root of b squared minus 4ac. This part right here is what we call the discriminant. Please know that word. And it is called the discriminant because it tells us how many answers we're going to get. Okay? It discriminates against all its other buddies. And these are the rules. They're all right here. They should all be printed in your page and they should already be highlighted. So, before you even attempt the quadratic equation, it's a good idea to have a look at the discriminant so you know what your answer is going to look like. Understand what I'm saying? If you just check this and you're greater than 0, then you're going to have 2 answers. So this is like number 2 above. If it's equals 0, this is number 1. You'll have no root, or 1 root.
Wait, so if it's that one, is it just a line? Or?
I'll show you in a sec. And this one is number 3 with no roots. Everybody cool? Now, we're going to do 2 things right now. We are going to practice our calculator work, and you're going to see what these things look like. Okay? You do not need to do all 9 of them. We're going to do number 1, 2, and 3. Okay? So everybody get out their calculators. I have mine right here. Clear everything off and hit that Y equals button on the top left. So you're looking at, so you're looking at a blank screen. Everybody got their calculators set? Come on. All right, so let's go up and let's just do A, 1A. So let's punch this in exactly as we see it. Let's make sure we remember how to do this, okay? Since it all equals 0, we can punch it in just like this, remembering that this is Y. Everybody cool? So on our calculators, we're going to punch this in. What button do we punch to get a variable? The xt theta n button. X. X is squared, so we're going to push the x squared button, which is right over here on the left. Everybody to there at least? Okay. Is that minus or is that negative? I had to wait for my red dot to pop up. That is, my red dot doesn't want to follow me. That is minus. Do not hit the negative button. It is minus 8x plus 16. Everybody cool? Everybody should have that in their screen, yes? Now graph it. Hit your graph button. And this is what it looks like. Everybody got it? Now, Bryce, this is what it means by having 1 root. You will notice that the parabola only touches the x-axis once. It bounces off at the x-axis. And what is that point?
Apparently, according to its guess, 3.9999997, but probably 4.
It is 4. Everybody cool? Everybody understand? Now, we can do a lot of stuff with our calculator there. Okay, we can identify the vertex and the x and the y intercepts of each graph. Okay, we're going to do that right now. The vertex, that's where it turns. Okay, so we've got 1 vertex here, right? So we are going to go second, trace, but that you can see when you hit the second button, it's calculations, and it gives us a whole bunch there, right? Now, do you see the word vertex there? We want a vertex, and yet the word vertex is not there. But the word minimum and maximum is there. What on our drawing, which we know to be a U that looks like this, is that vertex a minimum or a maximum? Minimum, because it's English, right? The whole graph goes up from there, correct? So that makes this a minimum. So what button are we going to push here for what we want to do? Are we going to push 3 or 4? 3. We want a minimum. Now, we know how to do this left and right boundary thing. I got to go to the left of the vertex. So I move my little target which isn't on the screen yet. I got to get my target onto the screen. Here it comes. There it is. Is my flashing target to the left of my vertex? Yes. So I can hit enter. Now I need the right boundary. So I got to move my little flashing target to the right of the vertex. Is it to the right now? So I can hit enter. Then it's going to ask me to guess. And there we go. Everybody cool? Now Bryce says it should be 4. Well, that's 1, 2, 3, 4, 5, 6, 7. That's 9,999,997 10 millionths.
Yeah, that's not 4, is it?
Bryce, due to wise acidness, I am assigning you the research project as to why the TI-84 tells me that that is 3.999999997 and not 4, when we know it to be 4. Deal?
If I remember.
I know it's cool. You probably won't. But you have a point, and I would like for you to know your answer. I am teaching a man to fish.
I thought you were going to point out that that's like enough to calculate the radius of the universe accurately, but...
All right. Is everybody cool? Was everybody able to find their minimum? And everybody understands why it's a minimum? Okay. Now I also asked for the x and the y intercepts of each graph, yes? Everyone agree? Okay. So I need the x and the y intercepts. So I'm going to go into calc again. Now, which of those do you think will help me find an x and a y intercept? We already know which one finds the x-intercepts because we've used it already before spring break. Zeros. And the 0 is exactly the same as what we just did. You find the spot where it touches the x-axis and you go on both sides of it. Left, right, boundary, guess. And in this case, it's going to come up with what? 4 again, because it only touches the x-axis once. Everybody cool? Now the next one is a little bit trickier. I need the y-intercept. None of those words say intercept, do they? But that first word says value, doesn't it? What happens when we hit number 1? X equals blank. What number should I put there? Hold up. Some of you are saying 4. If I put x equals 4, and I hit enter, what's y? 0. That's not the y-intercept, is it? Nope. So second calc. What must I have to put in for x to get the y-intercept? 0. Because when x is 0, we get the y-intercept. And look what you get. 16. Don't we see 16 somewhere in that equation?
Oh crap, it's a y equals mx plus b situation.
It is very similar to a y equals mx plus b situation. Everybody cool with that? So, right now, you should be able to tell me just by looking, what is the y-intercept on B? No calculator. 9. What's the y-intercept on C? 1. Everybody cool? Picking up what I'm putting down? Read my mail? Mow my lawn?
No, I don't read your mail.
No, nobody reads my mail. I don't even read my mail. Goes straight into the recycling.
All your bills.
All my bills. I pay everything online. It's 21st century. Everybody cool? Okay, now you guys do B. 2A, I mean. Do 2A. Punch that in. Tell me the vertex. Make sure we can do this. So I'm going to clear that, and I'm going to punch in my new one. 2B.
2B. I already put in 2A.
Or 2A, I'm sorry, yeah, 2A.
Well, now I already cleared it.
Shut up, Bryce.
I just cleared it as you said it, damn it.
And then graph it. Now, this one looks weird. Right? How many people have a graph that looks like mine?
Yeah. Well, yeah.
What's missing? The vertex isn't there, is it? It's not on the screen. Do we need it to be on the screen? No, we don't. Right? Because as long as we can get to the left or the right of it, we can use the calculator, can't we? Or we can do this. Window, and we can change our scope of what we're looking at. I can make my X maximum and X minimum. Were my X's okay? Yeah, I can see my X's. I don't need to change them. But my Y's are no good. Where do I need more Y's? Up or down? Down. So is that Y minimum or Y maximums that I need to change? Y minimum. That needs to get lower. How much lower do you think? Who knows? But you can put anything. 40. Now, please notice I can change my Y scale. Right now, every spot on the calculator is 1. If I change that to 5, every spot on the calculator is going to be 5. Do you understand what I'm saying? So the first one down will be 5, the second one down will be, third one, fourth one, 20. So if we go down to minus 40 and I change the Y scale to 5, there's going to be 8 clicks going downwards. Does everybody understand that? Yeah? So I'm going to change this to 5, and then I'm going to regraph. Cool? Now I can see it. Now is this vertex a minimum or a maximum? Minimum, because the graph goes up. So I go second, calc, minimum, 3. Am I on the left? There's my flashing dot. Is it to the left of my vertex? Nope, so I got to move it. You guys can just hold down the button. My piece of crap, I got to tap it 1,000,000 times. So now I'm to the left, enter. Then I got to go back to the right. Enter, yes. And there's my minimum. Negative 2.5 and negative 20.5. It even gives me the X and Y coordinates. Was everybody able to do that? Okay. We already know the roots are going to be 7 and 2. Yeah? Negative 7 and 2. We already know that. So we're not even going to check it. And we already know our y-intercept is going to be what? Negative 14. Second, calc, value when x is 0. Negative 14. Everybody cool? Everybody cool? Now, Bryce wanted to know what these ones are going to look like, these number 3s with no roots. But you should already know that now, shouldn't you? Is it going to be a parabola? Yeah. Where's it going to live? Nowhere touching the x-axis. So everybody graph number 3. 3A.
I don't think we're done.
No, he's mocking me because he said B the second time and I changed it.
And then he got mad at me. Now you will notice that it's on our yucky changed window, yes? You can always change it back by doing zoom 6, zoom standard. That's a 10 by 10. And there it is. And see, Bryce, it's still a parabola. It just doesn't touch the x-axis anywhere. So it has no x roots.
Parabola. parabola? I think you mean the parabola.
The Y scale. Yes. Yes. A zoom standard is a 10 by 10 on a scale of 1. And see, if I hit the window button, Kelvin, 10 by 10 scale of 1. Okay? Joel.
It still has a Y.
Of course it does. See? So if I go second, calc, value, x is 0, y equals 6. Is everybody good? Can everybody utilize their calculators with these easy ones? Yeah? Okay. They're easy. I say they're easy because there's no decimals. And the numbers are small, so we can almost always fit them onto a standard window. Are your numbers going to be small in physics class? No, certainly not, right?
Though they come in easier format.
Okay. All right, so let us go, cabbages, and let's look at this one. Just use the discriminant for A and B here. So A, notice I only want the nature of the roots. I do not need the answer. I just need to know how many there are going to be. So what do I do here? I only need the discriminant, which is b squared minus 4ac. So what is the first one? 6 squared minus 4 times what's a? 9. What's c? 1. So that's 36 minus 36. That's 0. So how many roots do I have? 1 root. I don't care what it is. I only wanted 1. Now look at B. Oh my goodness, it's enough to make you poop. What are we going to do with that? Is it in the right form? No. So how do we need everything on the same side, yes? So right away I need to make this 3x minus 4 over x minus 5 equals 0. What's wrong with that?
Can you just multiply everything by x?
You got to multiply everything by x because you're not allowed to have that fraction. So multiply everything by x to get 3x squared minus 4 minus 5x equals 0. Am I in the right form? No. Why? Yeah, it's in the wrong order, isn't it? So I rewrite it. 3x squared minus 5x minus 4 equals 0. Now can I use the discriminant? Yes. Why did I give you this? Because, you guys, if I had a nickel for every time one of you math students came to me and said, I can't do that, it doesn't look right, I would be a rich man. Okay? Because you are allowed to move things around and change how they look as much or as little as you need to. This is the exact same thing as this. Do you all understand that? Okay? So let's punch this in, or not punch this in, let's run it through the discriminant. What is B? -5, so squared. So it's going to be -5 squared minus 4 times 3 times -4, yes? Which is 25. Minus 4 times 3 is -12. -12 times -4 is what? +48. That's bigger than 0, so how many roots do I have? 2 roots. Everybody cool? Now I want to show you guys something. You don't need to do this. I just want to show you something. I'm going to enter this. 3x squared minus 5x minus 4. Everybody agree? That's what we got, yeah? I'm going to graph it, and I'm going to see that it indeed has 2 roots. Everybody agree? Yeah? Okay, now watch this. New line. 3x minus 4 divided by x minus 5. Does everybody see that this right here is right here? Did it graph the same way? Did it graph the same way? No, it did not, did it? We're going to learn how to do them too. Those are called hyperbola. Hyperbola. Okay, but I want you to look at something. I want you to look at something very closely when I get this other one back. Ready? What is happening?
Oh, I see.
Bryce already sees it because he's closer. Just wait, I'm going to do something.
Because I'm closer, dude, I'm half blind.
I'm going to zoom in on a very specific part of this graph. Observe. They hit the exact same spot on the x-axis. Even though they graph differently, they share the same root. And that's all we were looking for. Does everybody understand? They will both cross the x-axis at the same spot when y equals 0, no matter what they look like. Cool? Okay. How did I do what? That which 0 thing? Oh, the zoom thing? It's in Zoom, and it's Zoom box. And then you can draw a box around what you're looking at with your arrow keys. Okay? We're going to do lots of calculator work in a little bit, Kelvin. I'm just trying to get you guys the theory behind it. Okay? Because I know you don't believe me, because you guys have been raised to believe that your calculator is your deity in math class, and you should be, pouring lamb's blood out and having a candle and a big altar because your calculator is always right. It's not. The math is way easier on paper. You guys have just lost the skills of doing math quickly on paper. All right, so look at this question. Find the values of P, so this will have no roots. What part of this equation will allow me to have no roots? It's the discriminant, yes? What is the discriminant? It is b squared minus 4ac. If that is less than 0, there's no roots, yes? Okay, so what's b here? No. What's b in this equation? Yeah, what is it? What's p? P is b. So it's p squared minus 4. What's a? 1. What's c? 25. And all that has to be less than 0, doesn't it? So p squared minus, what's 4 times 25? P squared minus 100 has to be less than 0, yes? So p squared has to be less than what?
10. Wait.
P squared has to be less than 100. So P has to be less than the square root of 100, right? Which is what? Now, don't give me away, whacker! Now that he's, spoiler alert, Lucas Whacker in the class, what's wrong with that? Because all of you see 10, no problem. Square root of 100 is 10. But it's also what? Negative 10. So P has to be less than positive or negative 10. What? Isn't negative 10 less than 10?
So that has to be less than negative.
If it has to be less than 10, doesn't that include negative 10?
Mm-hmm.
So technically this would be every number to the left of 10 on the number line, yes? Does everyone agree? Does everyone agree?
Mm-hmm.
So all of these numbers down here till when? Negative infinity, right? But what happens if I use negative 11? P is now negative 11. What's negative 11 squared? 121. 121 minus 100. Isn't that okay? Yeah. So it's not plus or minus 10. Where does this live? It has to be less than 10. But what else? Greater than negative 10. Because as soon as I go to negative 11, it doesn't work anymore, does it? Does everybody understand? Sit.
Is that like, because you put the negative from one side to the other, so the greater sign flips?
No, greater sign only flips if you do divide or multiply by a negative number. The reason for this is what Lucas just said. You got to remember that the square root of 100 is not only 10. Now, in other math we've done this very year, we've only cared about the positive square root, haven't we? But we know in parabolas, there's 2, right? So we got to be aware of both of them. Is everybody cool with that?
Well, why does it have to be more than negative 10?
Well, because of what I just did. If I make P negative 11, what's negative 11 squared? Positive 121, right?
Mm-hmm.
And then 121 minus 100 is positive.
Mm-hmm.
And if there's a positive root under there, there's 2 answers. I want no roots.
Oh, because you want...
Right? Do you understand? So if I have negative 9, it's going to be 81 minus 100, and that's no good.
Yeah, sorry.
If I have positive 9, it's going to be 81 minus 100.
I just missed the no real roots part.
Okay. Everybody cool? So you guys now do that exact same thing on your own. Actually, I'm going to shut up and give you... Turn the page. Do everything up to your practice test. Mm-hmm. Of course, yep. And see you. You know what, Larry? Make sure you do the practice test for homework.
Okay.
Page 92 and 93.
Okay.
Okay, now guys, spring break fell weirdly, right? It fell at a bad time in the book for just the way we've been, for the pace our class has been moving, okay? Now, normally when I give you a practice test, that means you've got a test coming up, right? I'm not incredibly keen on testing you with a big test right now. but we're going to shift gears significantly in the next day or two away from algebra and into graphs. Okay? So we're going to do a small test on algebra, not just the quadratic formula and completing the square, which you just did a quiz on. We're going to do one that puts it all together with a calculator question or two. All right? And I want to do that on Thursday, 3 days from now. Okay, so that practice test you'll do tonight. We'll mark it tomorrow. And then you'll have Wednesday. And then on Thursday, because it's a short day, we'll do that. Cool? I don't know if Thursday's X block or collab. Okay, but regardless, it's a short day. Okay? Luda? Great. And that quiz will look exactly like page 92 and 93, except there will be one calculator question. So you'll get an equation. It might be in a weird form. You might have to move it around a little. Tell me what the graph looks like, and then some information about it that you get from second calc. Okay? Everybody cool? All right. So I'm going to write this down at the end of tonight's notes to make sure everybody is comfortable with this. You are working on up to 92 in class. Practice test for homework. And Thursday will be a quadratics and calculator. I'm only going to call it a quiz because it's not big enough to be a test. Yeah, I have it right here. I'm going to give it out right now. That's why I want to stop lecturing. I want to make sure everybody's good. Okay, carry on. Now, as soon as I give out this